Hello, I'm Miss Adams, and I'm here to help with graphing absolute value functions. The general form of an absolute value function looks like this, where f of x equals the absolute value of mx plus b, and then plus c. Now keep in mind this behaves very much like a linear function, and that's why you can see part of a line in the graph. Now keep in mind whether I talk about the absolute value of something, say positive 5, or the absolute value of negative 5, they're going to produce exactly the same result. So what ends up happening in the graph is you'll get what looks like a reflection, kind of like what my hands are doing here, where the hand is flipped over, you get a reflection. So this side of the line gets reflected over the axis line here that I've placed in. Now what does plus c do? Well, let's take a look at a particular equation and see. So I'm going to start with the equation without the plus 1, and I've chosen some particular input values, 3, 4, and 5, and that will produce an output values of 2, 0, 2. Now please pay attention to the pattern you see. Around this 0, you'll see the same exact points. So those show up as what we refer to as symmetry points. The 0, which means that's going to be our distance. Remember, absolute value has to do with distance. The lowest distance we can have is at 0. And that's why at 0 we get this vertex, which is often referred to as a turning point, around which the reflection occurs. Now, what does the plus 1 do? It basically says that all the y values are going to increase by 1. So what happens to the graph is each point moves up 1. So you can see now the absolute value function, or this V-shaped graph, now is 1 higher in all places. All right, so let's have you think about this one, where we place a negative in front of the absolute value. Here are some input values to consider, and then go ahead and see if you can graph it. When you're ready, you've got your graph, go ahead and click on Continue. Okay, did you guess you're not only going to get the reflection within the graph, but you're also going to see a reflection over the axis. So the V will actually appear upside down. So let's see why that's the case. It's placing in a negative 4 into the absolute value. Negative 4 plus 3 is negative 1. Absolute value of negative 1 is positive 1. But we have this negative in front, so it's going to put us back at negative 1. Negative 3 plus 3, there's our smallest distance at 0. The opposite of 0 is 0. And then when we go to place negative 2 in, negative 2 plus 3 will produce positive 1, which has the same absolute value as negative 1. And then with a negative in front, you're going to see that pattern again of symmetry, negative 1 and negative 1. All right, so let's go ahead and plot those points. We've got negative 4, negative 1, which would be here. We have negative 3, 0, which is there, and negative 2, negative 1, producing that symmetry. So the graph, as you can see, will turn upside down. So when you're looking at an absolute value equation, remember it will form a V-shaped graph, either right side up or upside down, such as we saw here. The inside will behave like a linear function, and then we get a reflection onto the other side. Okay, so a linear graph with a reflection. The plus 1, if you have a constant of any sort, will cause a shift. Positive will shift up. If it were, say, negative 5, it would shift everything down 5. The negative in front of the absolute value causes a reflection so that the graph is upside down. All right, so there's your basics dealing with absolute value and how to graph them. You're all set. Give it a go.
Hey guys, this is Mr. Scott, and I will be helping you with graphing vertical translations. Let's begin by defining some key terms. First we have an absolute value equation. This equation has a V-shaped graph that points upward or downward. Next we have translation, which is a shift of a graph horizontally, vertically, or diagonally. We will be focusing on vertical translations. When dealing with the translation, you have a parent equation of the form y equals the absolute value of x, and a translation equation of the form y equals the absolute value of x plus k, or y equals the absolute value of x minus k. If you have an equation of the form plus k, you're making a translation up k units. And a translation equation of the form minus k translates the parent equation down k units. So it's important to understand the relationship between the parent equation and the translation equation that you're working with. It all has to do with the value of k. Now let's work through an example together. Here we want to graph the equation y equals the absolute value of x plus 2. So let's start with the parent equation. We want to graph the equation y equals the absolute value of x. Since it's a parent equation, it has its vertex at the origin. Remember, absolute value equations have a V shape to them. So here is the graph for y equals the absolute value of x. Now, where do you think the vertex of y equals the absolute value of x plus 2 should be? Remember, the vertex for y equals the absolute value of x is at the origin. Do you think the vertex of y equals the absolute value of x plus 2 should be at 2, 0, 0, 2, 0, negative 2, or 2, 2? Choose A, B, C, or D for the correct location of the vertex.
That's right.
Yeah, you are correct in choosing B, 0, 2. The value of k in our equation is 2, so we need to translate the vertex and all the other points of the parent function up 2 units. So we're translating y equals the absolute value of x up 2 units. And here's what our graph will look like. It's a V-shaped graph with the vertex at 0, 2. All right, that wraps up our example. Remember, when working with translation equations, to understand the relationship between the parent equation, y equals the absolute value of x, and the translation equation. A positive value of k, or I should say a plus k, in the equation means shift the graph upward, and a minus k in the equation means shift the graph downward. Great job working with vertical translations, and work well. Welcome everybody, my name is Mr. Scott and I will be helping you with the equations for vertical translations. Let's begin by discussing the relationship between the parent equation and vertical translation equations. The parent equation is y equals the absolute value of x. One vertical translation equation is y equals the absolute value of x plus k. This equation translates the parent equation up k units. The other vertical translation equation is y equals the absolute value of x minus k. And this equation translates the parent equation down k units. So use these two forms of vertical translation equations to write your equations when dealing with equations for vertical translations. Let's work through this example together. Here we want to write an equation for each translation of y equals the absolute value of x. Remember, that's the parent function, or parent equation. Well, go ahead and look at parts A and B and try to think of the equations that will match those two situations, and then hit the continue button when you're ready to start the problem with me. Okay, welcome back. In part A, since our movement is down, we know we're working with the y equals the absolute value of x minus k equation. And since our movement is 3 units, our value of k is 3. So all we have to do is substitute 3 into the equation for k. And that gives us y equals the absolute value of x minus 3. That's our equation. Now in part B, our movement is up. So we should use the y equals the absolute value of x plus k equation. And this time, our value of k is 7. So again, we want to substitute the value of k into the equation. And for part B, we get y equals the absolute value of x plus 7. Well, that was pretty easy, wasn't it? Great job working with equations for vertical translations. Remember to match the movement up or down with the sign of the equation you want to use, and then substitute the number of units in for k into the equation. Work well. Hello, I'm Mr. Scott, and I will be helping you with graphing horizontal translations. Let's start off by defining some key terms. First, we have an absolute value equation. This equation has a V-shaped graph that opens upward or downward. Next, we have horizontal translation, which shifts a graph left or right. Now let's discuss the relationship between the parent equation you'll be dealing with and the two horizontal translation equations. The parent equation is y equals the absolute value of x. The first horizontal translation equation is y equals the absolute value of x plus h. This translates the parent equation left h units. The other horizontal translation equation is y equals the absolute value of x minus h. And that translates the parent equation right h units. Now let's use this information to help us work through the following example together. We want to graph the equation y equals the absolute value of x plus 3. Let's start with the parent equation and graph y equals the absolute value of x. It's a V-shaped graph, and the point of the V, or the vertex, is at the origin. So here is what the graph looks like for y equals the absolute value of x. Now, where do you think the vertex should be for y equals the absolute value of x plus 3? Do you think it should be at 3, 0, 0, 3, 0, negative 3, or negative 3, 0? Choose A, B, C, or D.
Sorry, that's incorrect. Sorry, that's incorrect. Sorry, that's incorrect. That's right.
Yeah, D is correct. Negative 3, 0. So we're going to slide this vertex of the parent equation 3 units to the left. And in fact, we're going to translate the entire graph of y equals the absolute value of x, left 3 units. So here's what the graph will look like for y equals the absolute value of x, or y, x plus 3. Vertex at negative 3, 0. It's opening up and it has a V shape. So once again, that's y equals the absolute value of x plus 3. And that wraps up our example. Great job, and hopefully you learned from this explanation on graphing horizontal translations. Work well. How's it? My name is Mr. Scott. I'll be helping you with equations for horizontal translations. Let's begin by discussing the relationship between the parent equation and the horizontal translation equations you'll come across. The parent equation is y equals the absolute value of x. Now, one horizontal translation equation is y equals the absolute value of x minus h. This equation translates the parent equation right h units. The other horizontal translation equation that you'll come across is y equals the absolute value of x plus h. And this equation translates the parent equation left h units. Let's use these two forms of the horizontal translation equations to work through an example problem together. Here we want to write an equation for each translation of y equals the absolute value of x. In part A, our translation is 4 units right. So what do you think the value of h is for part A? Once you think you have the correct value of h, hit the continue button to move on. Alright, welcome back. The number of units that you are translating is your value of h. So 4 is our value for h in part A. Since we're translating to the right, we want to use the form y equals the absolute value of x minus h. So all we have to do here is substitute our value of h into the general form. And that gives us y equals the absolute value of x minus 4. That was pretty easy, wasn't it? Let's move on now and take a look at part B of this example. In part B, we're translating 5 units to the left. Remember, the number of units that we're translating is our value of h. So h equals 5. This time, however, we're translating to the left. So we need to use the general form y equals the absolute value of x plus h. Again, we need to substitute our value of h into the general form. And for part B, we get y equals the absolute value of x plus 5. And there you have it. Remember the steps. Decide which horizontal translation equation you're going to use. Y equals the absolute value of x minus h if you're translating to the right, or y equals the absolute value of x plus h if you're translating to the left. And the value of h is the number of units that you are translating. Great job working with equations for horizontal translations. Work well.